Hello dear students, so this is our next derivation number 10. It's relation between electric field and potential difference. Okay, not very favorite from exam point of view, but I have included this in the series of videos because you never know, nowadays in physics paper they are picking up things which have not been asked generally. So this is more of a practical application thing, not a derivation thing, but just from a for the sake of comprehensiveness, this derivation is there. Okay, relation between E and B. So we are talking about this relation: E is equal to minus del V over del R. Del is differentiation only; it's like dV by dr, but it's a partial differentiation. Right? We have spoken at length about this partial differentiation in our regular offline classes. Right? So what this means, right? Let's say if you have to calculate the electric field in x direction, so you do partial differentiation of V with respect to x. That means you take y and z as constants. When you do Ey, that means electric field along y direction, you differentiate same potential but not taking y as a variable, taking x and z as a constant. Similarly this. Okay, so this is from application point of view, but here in this video we'll talk about deriving this formula. E is equal to minus del V over del R. So let's just get started. So it's a typical derivation. It has its own setup, right? A context. So you have to derive it like this only. We are considering two equipotential surfaces, surface A and surface B. Surface A is below, surface B is little above, like that. And visually, if you want to talk about. Okay, so these equipotential surfaces are there. That means all the points on surface A, have same potential, which is potential V, and all the points on surface B is having potential V plus delta V, right? Well, this is the direction of electric field. We are considering 2 points, point A and point P, right? The perpendicular distance between point A and P is delta L. That means there are 2 surfaces, so delta L is the difference between, it's the distance between these 2 surfaces, perpendicular distance, like this, perpendicular distance. Okay, so this is what we have considered here. Okay, now we know that potential difference, whenever there is potential difference in question, we are talking about work done in moving a unit positive charge. So that's how we will start. So if you consider a unit positive charge which is at surface B and we are bringing it on surface A, so work done in moving a unit positive charge from B to A, right? This will be equal to force will be Q into E. E is the electric field, Q into E is the force, and displacement is delta L, right? So Q into E into delta L is my work done. Now why it is like positive? Because if you see here, electric field is like this. So when you are bringing a positive charge, the force of electric field will be along the direction of electric field. So you will have to apply an external force. So external force will be in the direction of displacement. So this work done will be positive, which is Q into E into delta L. Now Q is 1 because we are talking about a unit positive charge. So taking Q as plus 1, this turns out to be W is equal to E into delta L. Right? Now once we have got the work done here, by definition this work done is equal to what? It is that potential difference between the 2 points VA minus VB. We are coming from B and to A, right? VA minus VB. Understand? We started at surface B and now at surface A, right? So this will be VA minus VB. So VA minus VB has to be equal to E into delta L, because this is by definition the work done in moving a unit positive charge, E into delta L. So if you put VA as V, and VB as V plus delta V, so what this will become? V minus V plus delta V, VA minus VB is equal to E into delta L. Now VV gets cancelled, minus delta V is equal to E delta L. So E is equal to minus delta V by delta L, and in terms of small delta and small delta V, we can write this as E is equal to minus del V over del R. del V over del R. ठीक है, now we can write del V as minus E dr delta R. ठीक है, so we can also write dV is equal to minus E dot dr in terms of vector form. Obviously it is a dot product between electric field and the position vector, so this will be a scalar quantity which is dV, right? So if I want to know the complete potential difference, this same formula will be, you are moving from B to A, so RB to RA with a minus sign E dot dr. So sometimes the same formula is also written in this form, V as a function of E and dr. This is electric field with respect to the potential difference. Understand, when we are applying this formula, when we are differentiating this function, this minus sign is important. Let's say you are differentiating with respect to x, and this differentiation comes out as positive, and there is a negative extra. So the electric field will be in the negative x direction. So this minus sign takes, it's very important. You cannot just omit this. Okay? It tells you the direction of E. We can understand this concept better when we are moving in an electric field and when we are moving in the direction. That means in this scenario I have shown electric field is from left to right, like this. Let's say you move from A to B. That means you are moving in the direction of electric field. Whenever you move in the direction of electric field, potential always drops. That means A will be at a higher potential, B will be at a lower potential. VA will be greater than VB. Okay? That's how you interpret this minus sign. When you are moving in the direction of electric field, potential drops. That's why there is a minus sign. Moving in the direction of electric field decreases the potential. So this is something you have to remember, and while applying, this is more important. This formula may get confusing with a minus sign, but you have to remember this thing. This minus sign is only for when you are moving in the direction of electric field, potential is dropping. Okay? Okay. If you have a uniform electric field, for uniform electric field, this formula will take a different shape because E will be uniform, so it will come out of integration as a constant. So this will become delta V is equal to RB to RA with a minus sign E dot dr. E will come out. When E comes out, this will become RB to RA dr. RB to RA dr would nothing be the difference between these two, the distance between these 2 points, that is D. So this formula will become VA minus V is equal to minus E into D. So remember this thing, for a uniform electric field, if you are moving in the direction of electric field, this will become your formula. VA minus VB is equal to minus time. So you can see here, if you are moving in the direction of electric field, VA minus VB would be, you are moving like this. Right, so VA minus VB should be negative because you are moving in the direction of electric field. That's why it will come negative. Okay. So you don't have to bother about whether I should use this minus sign or not use this minus sign, because generally you are, when you're talking about electric field and potential difference is a quantity which is just a difference, right? So when you're talking about difference, positive and negative is not that important, right? Understand? So difference, you are mainly concerned with a value, and the value would be हमेशा E into D. आप इलेक्ट्रिक फील्ड लो, D से मल्टीप्लाई कर दो, you will get the potential difference. अगर पूछा जाए कौन सा पॉइंट ज्यादा पोटेंशियल पे है, कौन सा लोअर पोटेंशियल पे, then you have to apply this concept. Have I moved in the direction of electric field? क्या मैं इलेक्ट्रिक फील्ड की डायरेक्शन में मूव कर रहा हूँ? तो इसका मतलब ये है कि जहां पे मैं जा रहा हूँ वहां पे पोटेंशियल कम होगा, और जहां से मैं आ रहा हूँ वहां पोटेंशियल ज्यादा होगा. ये जैसे इस केस में मैं B से आ रहा हूँ और मैं A पे जा रहा हूँ. अगर मैं B से आ रहा हूँ A पे जा रहा हूँ, इसका मतलब B पे पोटेंशियल ज्यादा होगा, A पे पोटेंशियल कम होगा, तो VA माइनस VB विल बी नेगेटिव. आपको बस इतना याद रखना है कॉन्सेप्ट वाइज. ठीक है. वैसे तो मैंने क्लास में बहुत सारे एग्जांपल्स कराए थे इस कॉन्सेप्ट के, यहाँ पे डेरिवेशन की बात कर रहा हूँ, बट इन केस राइट आप भूल चुके हो तो मैं फिर से आपको दिला दूं. अगर मान लो इलेक्ट्रिक फील्ड मेरी इस तरीके से हॉरिजॉन्टल डायरेक्शन, दिस इज माय E, ठीक है, ठीक है, और आप ऐसे भी नहीं मूव कर रहे हो, ऐसे भी नहीं, आप कुछ मतलब यू आर मूविंग एट एन एंगल लाइक दिस. तो अब क्या होगा, अगर मुझे किसी ने VB माइनस VA पूछा तो मैं क्या करूंगा? तो क्या मैं इस टाइम, अगर ये डिस्टेंस मेरी लेट्स से दिस डिस्टेंस इज L, तो क्या मैं इसको E इंटू डी, क्या मैं E इंटू एल कर दूं? गलत हो जाएगा, गलत हो जाएगा। क्यों? क्योंकि आपने ये फॉर्मूला डिराइव किया है, इस केस में आप मूव कर रहे हो इन द डायरेक्शन ऑफ इलेक्ट्रिक फील्ड, राइट? यू आर मूविंग टोटली इन द डायरेक्शन ऑफ इलेक्ट्रिक फील्ड, ईदर लाइक दिस और लाइक दिस, बट आप एंगल पे मूव नहीं कर रहे हो, आप इलेक्ट्रिक फील्ड के अलोंग मूव कर रहे हो। बट यहाँ पे आप इलेक्ट्रिक फील्ड के अलोंग मूव नहीं कर रहे हो, तो आप सिंपली यहाँ पे E इंटू एल कर दोगे तो हो जाएगा गलत। आपको क्या करना है कि आपको A से B तक जाना है, तो आप A से B तक कैसे जाओगे? पहले A से C जाओगे अलोंग इलेक्ट्रिक फील्ड, और फिर परपेंडिकुलर टर्न करके ऐसे जाओगे। तो आप ये याद रखो कि जब आप C से B जा रहे हो, मतलब परपेंडिकुलर, यू आर मूविंग परपेंडिकुलर टू द इलेक्ट्रिक फील्ड, देयर इज नो पोटेंशियल चेंज। पोटेंशियल एट ऑल द पॉइंट्स ऑन दिस लाइन BC विल बी सेम। सो जो भी आपको पोटेंशियल डिफरेंस VB माइनस VA निकालने के लिए बोल रहा है, वो बेसिकली VC माइनस VA निकालने के लिए बोल रहा है, क्योंकि VC माइनस VA और VB माइनस VA सेम होगा। क्यों? क्योंकि C और B के पोटेंशियल सेम है, बिकॉज आप इलेक्ट्रिक फील्ड के परपेंडिकुलर मूव कर रहे हो। ये कॉन्सेप्ट मैंने आपको क्लास में बताया था कि जब भी आप इलेक्ट्रिक फील्ड से परपेंडिकुलर मूव करते हो तो पोटेंशियल में कोई चेंज नहीं होता है। तो इसका मतलब आपको यहाँ पे E इंटू डी करना है, विच इज यू हैव टू जस्ट सी हाउ मच यू हैव मूव्ड इन द डायरेक्शन ऑफ इलेक्ट्रिक फील्ड। बस समझ में आ गई बात? हाउ मच यू हैव मूव्ड इन द डायरेक्शन ऑफ इलेक्ट्रिक फील्ड, बस वही वाली डिस्टेंस आपको कंसिडर करनी है, आपको ये वाली डिस्टेंस कंसिडर नहीं करनी है। तो प्रॉब्लम में आप कंफ्यूज नहीं होंगे। आप सिर्फ जब भी आप VB माइनस VA इस केस में निकालेंगे, जब आप यू आर मूविंग एट एन एंगल इन इलेक्ट्रिक फील्ड, जस्ट टेक द डायरेक्शन मूव्ड अलोंग, just taking the distance moved along the direction of electric field. I hope this is clear. So this will be the case. Thank you very much.